So Allyn is here to ruin our idea of game benchmarking. Well, really game benchmarking and storage benchmarking, but in the best possible way,
Just
starting with
benchmarking in
Factorio. You're benchmarking Factorio wrong.
A lot of people are benchmarking Factorio wrong.
Yeah.
Yeah, we're going to spoil it.
Sorry.
Spoiling it for everybody. Sorry, guys.
So the context for this video is AMD 7950X3D versus 12900K, 13900K, 13900KS. When looking at indie gems like Factorio, the 7800X3D, 7950X3D, it's 200 updates per second. It's phenomenal. And it is phenomenal, but it's not 200 updates per second versus, it's not got 200% gains.
Here's the flaw with testing Factorio. You can't just run it at 200 updates per second.
Because the game doesn't normally run like that.
The game never runs that fast. It's not like your regular game where higher FPS equals good, right? The game is faster.
So on Megadesk, it tries to run at 60 updates per second. And even if you run it unconstrained on the demo map that we're going to show you, you can still do 70, 80 FPS. But it's by design that it's only trying to do 60 updates per second. Even on fire-breathing 120 hertz OLED screen, 120 updates per second.
There's plenty of reviews that I've seen even recently. Everybody loves using this Factorio benchmark map, and it'll run on modern hardware at something like, 170, 200, something like that, right?
Well, 400 FPS on the 7800X3D, 170-ish on Intel.
400?
Yeah.
Jesus.
400
Okay.
updates per second.
So here's the problem. Yes, that's great. That's great. That's true. But that map, there's not enough stuff running on the map.
Yeah.
Obviously, because they're able to go that fast, right?
It's like you're switching between registers on the CPU. And it's like, why is that faster?
Yeah, because with an X3D, where you have all that extra cache, the map is so small that all of the content, or most of the content, fits in the cache on the CPU.
So
right?
coming at this from the other side of the coin, there is a famous streamer, if you can be a famous Factorio streamer, that...
Yeah, it's one of the famous ones. He does world records.
He's got the world record on Factorio, and it is a wonderfully complicated map. Check this out. Look, there's a rail system. You can... Actually, the rail system is even so insane that the train goes, and the train gets to the end of the line, which deploys robots, which then deploy more robots, which then deploy the infrastructure.
So that the factory must grow. That's it.
Yeah.
It's a train network just to grow the factory. Yeah.
And so... This is an absurdly huge map. You would never normally... You can beat the game long before this, and so this is a really crazy situation.
Right. But the key is, it's enough of a map to slow the system down much closer to 60.
Yes.
Right? So you have enough content to where that 60 number actually becomes close to what where you would notice that the game was, bogged down enough.
Real map, real player, real stuff happening in this map as opposed to a smaller, less complicated map.
Right.
And so in this lens, you're never going to get 400 updates per second on this map with this level of complexity. Right. And the AMD X3D CPU still wins, but it wins by 15%, 20% at the most.
Right. It's no longer a 170 versus 400. Oh my goodness, it's 3 times faster.
And this is this subtlety is important to understand when doing benchmarking, because it's not necessarily that cache is better. I mean, cache is better in this case, but it's not really giving you the whole story, which is interesting.
Right. The workload has to be big enough for this game, right? Now, don't get me wrong, like X3D is doing plenty of good things for other stuff. It's just that for Factorio in particular, you have to be a little bit more careful about the...
And Factorio is also... Yeah, there are a lot of people who are reading too much into just one benchmark.
Yeah.
And more recently, like the Jedi, Star Wars game.
The new Star Wars game?
Yeah, it runs great on Vcache CPUs, but they just patched it to be less awful on literally anything else. And that's just bad engineering.
But the whole, that concept of having a full grasp of where the difference in performance on a particular benchmark matters also carries all the way over to the stuff I'm doing with the storage testing.
Yeah, and that's the other thing is we're gonna do a major update on the level 1 site, and I want to kind of do a blended benchmark that is real world and synthetic benchmarks for storage in a way that's a little different than what you see from other canned benchmarks. And there's aspects, like if you understand how PC Mark works, And if you understand how PC Mark does kind of a simulation playback thing, which is not exactly a block playback, but it kind of is a block playback. I want to know boot time. I want to know load time for games. I want to know, it's not just random I/O. It's like, okay, this random I/O is meant to be approximation of, loading something from disk, like a random program. But it's not really a good approximation because there's a little bit that's sequential and there's a little bit that's random. Okay, what actually would be that? And it's very hard to come up with a synthetic benchmark suite that really mirrors real-world use. You can make it something that's good for the synthetics, but then when you boot the system, it's like, why is the system taking 20 minutes to boot?
You're hitting the nail on the head so hard right now. As far as, because this comes up a lot, and every sort of benchmark, especially for storage benchmarks, it's just a matter of how close to real-world is it getting. That's what really matters.
Yeah.
Right? I mean, you can look at real-world benchmark or real-world usage traces and go, okay, there's an awful lot of 4K, random, QD1, there's an awful lot of that going on, and then you can do a synthetic test of just that one thing, but that doesn't give you the whole answer, right? That'll give you an idea of, okay, most of the stuff I'm doing is this particular thing. I can test that thing synthetically and get some sort of a result, and it's analogous, but it's not, this is what the performance will be when you're actually doing it, right? The best benchmark possible is to do the actual thing.
Something I've been working on since last year was using VFIO and passing through PCIe devices like storage. So I'd have a script that'll apply a Windows image at a specific point in time and then boot the system and then time how long it takes to run a startup script and then use that as a point of comparison. Yep. And that mostly works, but it's also a huge pain in the butt. And that Windows installation is frozen in time. It can never get on the internet again. Right. So forget using Steam. It's like, I want to time Shadow of the Tomb Raider opening. Well, you're going to have to use the cracked version of Shadow of the Tomb Raider that doesn't get on the internet because, again, non-deterministic.
Well, not only that, but anything that touches the internet, even if you let it touch the internet, that's a variable.
Yeah.
There's plenty of things that we've tried to time.
DNS took 300 milliseconds. Well, you've just wrecked your benchmark.
Right. And just the fact that there is a potential for variability there can completely throw benchmark runs, right? The internet went a little slower when we were testing this one particular SSD. Oh, all these results dropped by 10%.
Yeah.
Why is that? And it turns out it was just because the internet had nothing to do with the rest of the hardware.
Yeah, and that's one of the things that, PC Mark tries to do, and it does a pretty good job of what it does, but there's still holes, which is it tries to simulate a video conferencing application, and it tries to simulate a desktop publishing application, and it tries to simulate Microsoft Office.
You're talking the regular PC Mark.
Yeah.
Which is actually running their own version of those apps, right?
Yeah.
That's reasonably good, right? Because it's not running the apps, but it's running apps that are doing the same job.
Well, some of it I think is they've actually traced the application because there's chunks of real DLLs and real applications in there, which is an interesting way to do it.
Well, yes, that's how the PC Mark storage test, the actual storage test that they do, works by just laying down a set of files because it's meant to run as close to real world as possible. They're doing the best they can with it being a trace benchmark, right? So it actually puts a bunch of files down, and then it runs the workload on those files. So it's a trace playback, but it's a trace playback that's smart enough that there was tools from 5-8 years ago that used to exist for trace recording and playback. You'd have to access the disk raw, right? It was just, here's the disk, I recorded my trace, okay, now I'm going to take some other disk, I'm going to swap it in. And this was similar to
That's when you have to do the imaging so that the same blocks contain the same data.
You would have to image the thing, or you would have to just write to the disk and completely fill the disk.
Good old block 47. It always contains this.
Yes.
It's hard to do that. There's a bunch of FIO scripts on the Level 1 forums that simulate Crystal Disk Mark and basic tests like that. But then when it gets to, I'm going to use FIO to simulate some of these more complicated things, you also run into issues there, which haven't been a lot of fun. And it's just, there's a reason the saying goes, lies, damned lies, and benchmarks.
Yeah. And, even with something like FIO, even as deep as you go on technical knowledge of exactly how FIO works, and, I know I can do exactly this workload, just the mere fact that if you're trying to run FIO on a drive that's already partitioned, well, now you can't access the drive raw anymore. It has to do it on a file, right? It needs to put a file there and then do the work on the file. Well, just by putting the file there, you have now altered the performance of the drive.
Yeah.
Right? So it's almost like you have to have the foresight of, okay, I want to see what this drive looks like 6 months from now. Well, unless you put the file there 6 months ago, you're going to alter the performance. There's even stuff I've run into recently where I had a job that was writing and then reading and then removing 100 gig files to just something on Linux, right? So it gave me a chance to choose different file systems and different file system configurations, right? I was trying XFS, I was trying ext4, and like each one had a different way of falling on its face, trying to do like some background cleanup. And it wasn't trim, because I was using Optane SSDs. So we know trim doesn't care about trim, right? But it was the file system itself that was doing something, and it was interfering with the write speed of the next file. So it was like you deleted a big file while you were writing a new file, and then the performance would like cut in half for some like 15, 20 seconds.
And that's really bad if you're relying on me to tell you this SSD is better than this other SSD, because it might not actually matter, especially if the SSD is looking into that and says, oh, I know how to deal with this, and I can...
But think about that scenario I just described is not something FIO would do.
Yeah.
Right? Because it's not deleting a file. It's not causing the file system to do what it would need to do upon a file deletion, for example. Right?
Well, we know also from benchmarking Samsung SSDs that Samsung SSDs look for certain patterns from NTFS specifically. So the firmware has stuff in it that's like, oh, you're using the NTFS file system. I got you, fam. But it's like, that's not great from a benchmarking perspective either, because what if you're not using NTFS?
OCZ started that. That's a carryover from OCZ before SSDs were supporting trim.
But this is the kind of thing that we deal with when we're trying, like, we worry about it. You know, there's a lot of people that don't worry about it, but when we're doing benchmarks, or at least, you know, when I'm trying to put together a benchmark, these are the kinds of things that I worry about, and this is some of the hesitation that you may sense sometimes when I'm like, well, here's my numbers and here's my Phoronix test suite, but you know, take this with a grain of salt. Or you need to understand a little bit about how it works and how it applies to your situation. You can't just blindly accept that Factorio is going to do 400 updates per second, which again is amazing. That's really good, you know, awesome stuff. But that doesn't mean that you're going to experience 400 updates per second unless you have a trivially small map and you turn off some things to make Factorio run faster, which nobody ever does. It's considered a cheat, actually. But
yeah, I mean, that same sort of thing applies, again, back to the storage. But if if Wendell publishes some fancy results from some new suite that he comes up with, you have to consider what hardware he got those results on and where the bottlenecks in that hardware might have influenced, that drive only went this fast on that system. Well, guess what? All of the other drives also only went that fast for that metric because the bottleneck, turns out, wasn't the drive for that number.
To give you an idea of the level of insanity of stuff that I've already encountered, the direct CPU attached PCIe lanes are faster than not the chipset lanes, which has nothing to do with the bandwidth. It's 100% latency.
Yeah.
Nothing to do with bandwidth. It's like, oh, there's enough.
Well, not just latency. Sleep states for the link to the chipset, potentially.
Oh, yeah.
That's another thing.
Yeah, because the M.2 connecting to the chipset, that's always up and on, and it's working really good. But the chipset has the 8X link, and so you can be in a state where you've got enough bandwidth that it has to wake up and go to sleep, wake up and go to sleep, wake up and go to sleep, because that X8 link is not remotely saturated enough to really stay awake all the time.
Yeah, and where you run into that the most often is when you're benchmarking.
Yeah.
Why? Because you're not doing anything else except hitting the storage, right? If anything, it's on purpose, right? You don't want other stuff to interfere.
Yeah.
And it actually bites you in the rear end because you are too sterile.
Yeah.
There's actually such a thing as being too quiet.
So that already bit me in the butt on some of the CPU benchmarks for AMD EPYC, because if the PCIe bus never goes to sleep, that power is not available for the cores.
Yeah. And that's biting you in the rear
the other way.
The other way around, right?
And the controller on the SSD gets tired of waiting for the system to show up, so it will also go to sleep. Yeah. And these events chain.
Right. And so there's these sort of stacking impacts that can occur, but on a hair trigger of like, this SSD is 5% faster in reality. But if you test it with the power management and everything at the defaults, it looks like a 40 or a 50% performance difference. The key is having a good base set of tests that gets you all the numbers, that you don't have to go back and start retesting the stuff you tested like 6 months ago, right? You have to like standardize on some set of hardware so that you know your bottlenecks are static, and then. Well, I mean, I'm not teaching you anything you don't know. You know, you don't even update the firmware on that box. You don't touch it.
Well, we're also telling them what to look for in these kinds of benchmarks, which are not out there at all.
Right.
And it's like, I don't want to do this, but nobody else is doing it. Well, I guess I've got to.
Yeah. Well, I mean, that's the reason I had to make my own suite, because there was no off the shelf.
Yeah.
Definitely have
experienced that.
Yeah, the only way I was gonna get those results was if I made the thing that produced the numbers.
Yeah.
Right.
This is why benchmarking is hard. You heard it here first. All right, well.
The CPU stuff and the GPU stuff is super easy compared to the SSD stuff. It really is.
And the SSD stuff is only going to get more impossible.
Yeah.
Which is unfortunate. And this is just a tiny window into why, just so you know.
Yeah.
It's also a really easy opportunity to screw it up. So when you're looking at benchmarking, you can be like, what did they do wrong? And that's true of us, too. Like, well, we didn't have time to do it to the nth degree.
Listen. Happens to us.
Yeah.
It's our job to test these things. And we'll do a particular sequence of tests, and we'll see some results that we didn't expect. And we do this every day. Like, there's a whole group of people doing nothing but this. It's all the time. And we'll run into a weird thing, and we'll have to sort of do a debug call and go, okay, what happened here? Is the problem actually with our SSD that causes this regression or whatever? Or, 9 times out of 10, we'll go and we'll look at what was the sequence that you did? Show us the script, and we'll go, oh, 0, like, for whatever reason, this thing was supposed to wait 10 minutes, and it waited 0. Right?
Interesting.
And it's usually something as simple as that, where it's just, hey, we didn't give the drive any idle. Or you gave it idle, but the idle, and this is going to blow your mind, the idle was too good. The drive went all the way into deep sleep because there was 0 I.O. going on.
We talked earlier, like, one of the things for games is they do it looks like a random I.O. It's linear, but it's not really linear. But that's something their driver can deal with, not in the firmware by itself.
Yeah.
But in the chipset scenario, the extra latency would be more invisible because the driver was able to anticipate the I.O. request. And so the fact that the drive's a little farther away is actually beneficial in that scenario.
Yeah, you get a better boost from the driver.
Yeah.
Right. It's at the end of the day, it only raises you back to the same performance that you would have got CPU attached with the driver anyway. It's just that the chipset attached, without the driver, is worse because of the extra latency. So,
fun times.
Testing.
Yeah, it's complicated.
Am I right?
Just to give you some insight. So I thought this would be a fun chat about benchmarking, starting with gaming and ending with storage. Thanks, Allyn, for coming.
Yeah.
Fun time.
I have to go.
Look for updates.
To go use the rack portal to get back home now.
I gotta talk Steve into adding something like this to the website, or his website, so that he can have like the ultimate storage benchmark database.
Well, between you and him, you could probably imagine if you standardized a set of hardware across both of you.
Yeah, that'd be nice.
And then you could actually mash the results together into one big database and have like twice the. Oof.
I'm going to make some notes.
It's getting dangerous now.
Fun times.
All right.
We'll see you later.